Right now, 7 kilometers from one of the most beautiful, most photographed islands in the entire world, there is a monster hiding beneath the sea. Not a creature, something far more dangerous than that. A massive underwater volcano, sitting silently on the floor of the Mediterranean, has been quietly filling with molten rock for nearly 400 years. Growing in the dark, building pressure. Until very recently, science had absolutely no idea just how serious the situation had become. We are talking about Kolumbo, an underwater volcanic monster located just 7 kilometers from Santorini. The same ancient region where a volcanic eruption thousands of years ago was so catastrophic, so total, that it practically wiped an entire civilization off the face of the earth. Kolumbo has not erupted since 1650. To most people, that sounds reassuring. Nearly 400 years of silence. Surely that means it is safe. But here is what volcanologists will tell you, and what makes this story genuinely terrifying. Silence is not safety. With volcanoes, silence can mean something far worse. It can mean accumulation, pressure, a system that has been recharging itself deep beneath the sea floor, completely out of sight, for centuries. Then came 2025. In the span of just 30 days, more than 30,000 earthquakes struck the waters around Santorini. The Greek government declared a state of emergency. Thousands of people abandoned the island. Scientists scrambled to understand what was happening beneath the seafloor. What they found did not calm anyone down. It did the opposite. Because what researchers discovered was not just one dangerous volcano preparing to stir. It was 2, connected, feeding from the same deep reservoir of magma, operating as a single, enormous, interconnected system, sitting beneath some of the most visited coastlines on the planet. 3 million tourists, 1 island, 2 volcanoes, sharing the same heartbeat underground. So the question you need to sit with as you watch this video is simple. Are millions of people unknowingly standing on top of the Mediterranean's most dangerous geological time bomb? And would anyone warn them in time? When most people think about volcanoes, they picture the same thing. A mountain, a cone of rock rising above the landscape, smoke curling from the summit, lava crawling down the slopes. It is an image so familiar, it has become almost comfortable. But that image is incomplete. And in the case of the Mediterranean, it is dangerously misleading. The most threatening volcanoes on Earth are not the ones you can see. They are the ones hiding beneath the ocean, invisible to anyone on the surface, building pressure in the dark, while the world above carries on completely unaware. There are more volcanoes beneath the world's oceans than on all of its land masses combined. Most have never been properly studied. Many have never been mapped. In the Mediterranean Sea, one particular stretch of ocean floor has been doing something scientists are only now beginning to fully understand. Beneath the blue waters northeast of Santorini, the Earth's crust is under extraordinary stress. This is the Hellenic Volcanic Arc, a geological collision zone where the African plate is slowly diving beneath the Aegean plate. That grinding, relentless process creates perfect conditions for large-scale magma accumulation deep underground. It has been running for millions of years and has produced some of the most violent geological events in recorded human history. The most famous happened around 1600 BCE. The eruption of Thera, a cataclysm so complete that it effectively ended the Minoan civilization, one of the most advanced cultures of the ancient world. Entire settlements were buried, coastlines were reshaped. The shock waves rippled through the ancient Mediterranean world in ways that historians are still untangling thousands of years later. That eruption came from this same volcanic arc, the same stressed, pressurized, geologically complex region that exists today. Along that arc, aligned to the northeast of Santorini, sit at least 25 submarine volcanic cones on the ocean floor, most unknown to the public, most unmonitored for the majority of modern history. Together, they form one of the most geologically volatile underwater landscapes on the planet. And at the center of that landscape sits Kolumbo, rising from the seafloor approximately 1,600 feet below the surface, deep enough to be completely invisible from above, its true nature hidden for most of human history. Nothing visible from the shore, nothing rising above the waterline. The surface tells you nothing. That is exactly the problem. To understand why Kolumbo matters so much right now, you need to understand what it did the last time it woke up. The year was 1650. Santorini was a small, quiet community of farmers and fishermen, a fraction of its current population, far removed from the mass tourism it carries today. On September 27th of that year, the seafloor northeast of the island fractured open with a violence no one on the surface could have anticipated. Kolumbo erupted. Pyroclastic flows, superheated mixtures of gas, ash, and volcanic debris moving faster than most people can comprehend, tore across the surface of the sea and reached the shores of Santorini. Toxic gases spread across the island in waves, choking the air and making entire areas uninhabitable. 70 people lost their lives. With a far smaller population and no modern emergency response infrastructure, it was a devastating catastrophe for everyone who lived through it. Then it stopped. And in the nearly 400 years since, Kolumbo has not made a sound. Generation after generation lived, worked, and eventually built one of the most visited tourist destinations on Earth, just kilometers from a system that had already demonstrated exactly what it was capable of. 4 centuries of silence felt like evidence that the danger had passed. But volcanologists will tell you that instinct is exactly backwards. Silence in a volcanic system is not inactivity. Beneath the surface, completely beyond human observation, volcanic systems operate on their own timeline, indifferent to how much time has passed above ground. Magma migrates through cracks in the crust. Chambers fill. Pressure accumulates. Heat builds. The longer the silence, the more material has had the opportunity to gather below. History is full of examples. Volcanoes quiet for 2 centuries before catastrophic return. Systems with no surface warning signs for generations, then released energy on a scale that stunned every scientist watching. Dormancy is not retirement. It is the interval between events. For Kolumbo, nearly 400 years of silence meant nearly 400 years of accumulation. A magma system doing what magma systems do in total darkness, with no one watching closely enough to notice. Until 2022, when researchers finally looked beneath the surface and found something that changed everything. In October of 2022, a study published in the journal Geochemistry, Geophysics, Geosystems announced findings that immediately caught the attention of volcanologists worldwide. The research team, led by geophysicist Kajetan Krawczyk at Imperial College London, had accomplished something no previous effort had managed. They had looked inside Kolumbo, deep into the interior of the volcano itself. And what they found forced a complete reassessment of the risk profile of the entire region. The technology that made this possible is called full waveform inversion. Think of it as a medical ultrasound applied to the Earth. Researchers fire acoustic waves from a vessel on the ocean surface down through the seafloor. When those waves travel through solid rock, they move quickly. When they encounter magma, molten, superheated, fluid, the speed drops dramatically. By measuring those differences across thousands of data points, scientists construct a detailed image of what lies beneath the volcano, a precise picture of the Earth's interior that no drill could reach and no camera could capture. What that image revealed stopped researchers in their tracks. Beneath Kolumbo, at depths ranging from 1.25 to 2.5 miles below sea level, sat a magma chamber nobody had known existed. It had never appeared in previous surveys, never shown up in traditional monitoring data. For centuries, it had been sitting there, completely undetected, hidden beneath the weight of the ocean and the sea floor above it. The chamber measured roughly 2,000 feet across, approximately 600 meters, and it was not empty. The total volume of accumulated magma measured 1.4 cubic kilometers. That number is hard to hold in any meaningful way, so consider it like this. That volume of molten rock, at temperatures exceeding 1,800 degrees Fahrenheit, would fill more than 500,000 Olympic-sized swimming pools, 500,000 pools of liquid rock, pressurized and sealed beneath the Mediterranean seafloor, 7 kilometers from a populated island. The discovery of the chamber alone was alarming. But as researchers examined the data further, a second detail emerged, one that in many ways was even more unsettling than the chamber itself. It was not static. It was not a relic of past activity sitting dormant underground. It was actively growing, and the rate of that growth would raise questions the scientific community could not easily answer. The growth rate researchers calculated is the kind of number that takes a moment to fully land. The magma chamber beneath Kolumbo has been expanding at an average of 141 million cubic feet, approximately 4 million cubic meters, every single year, not occasionally, not during periods of unusual activity. Every year, consistently, since the 1650 eruption, nearly 4 centuries of continuous accumulation, adding millions of cubic meters of molten rock to a sealed chamber with nowhere for that material to go. At that pace, within the next 150 years, Kolumbo's chamber could reach half a cubic mile, 2 cubic kilometers of magma. That figure is not a worst-case projection. It is the estimated volume expelled during the 1650 eruption itself. Kolumbo is not just growing, it is recharging, rebuilding toward the exact conditions that produced its last known eruption, methodically, year by year. The authors of the study were direct. They described the system as indicative of a highly explosive eruption, comparable in style, though potentially lesser in magnitude, to the Hunga Tonga eruption of January 2022. If that does not immediately register, it should. Hunga Tonga generated tsunami waves reaching 66 feet, 20 meters. Its eruption column punched into the stratosphere. The pressure wave circled the Earth multiple times and was detected on every continent. Now place that category of event 7 kilometers from Santorini, an island with 20,000 permanent residents receiving approximately 3.5 million tourists every year, concentrated into summer months, filling its clifftop villages with people who have no particular reason to think about what sits beneath the water nearby. And then factor in what makes the geography uniquely dangerous. The Mediterranean has no robust tsunami warning system. Unlike the Pacific, where decades of investment have produced detection networks capable of giving coastal populations at least some response window, the Mediterranean operates on distances too short and timelines too narrow. Waves generated near Santorini would reach surrounding coastlines in minutes. The chamber keeps growing. The clock keeps moving. And in 2025, the ground itself started sending a message. On January 27, 2025, seismographs northeast of Santorini began registering something unusual. A cluster of small earthquakes, tightly grouped, originating approximately 10 kilometers from the island's coastline, directly above Kolumbo. In the early hours, this resembled the kind of seismic activity monitoring stations record regularly in volcanically active regions. Clusters come and go. Scientists log the data and continue watching. But this one did not fade. The earthquakes kept coming. Through the first day, through the second, into February, and beyond. The swarm did not dissipate. It intensified. Over the following 30 days, more than 30,000 earthquakes were recorded between Santorini and Amorgos. The University of Athens reported over 15,000 individual events in just 15 days, a concentration with no historical precedent in the scientific record for this part of the Mediterranean. The largest tremor reached magnitude 5.2, strong enough to shake buildings and rattle windows across the island. The Greek government declared a formal state of emergency on February 6, 2025, remaining in effect until March 3rd. Schools closed. And in one of the more striking details of the crisis, residents were instructed to drain their swimming pools. The movement of large volumes of water in elevated pools during sustained seismic activity could destabilize structures already being stressed by continuous ground movement. Around 11,000 people left voluntarily. Hotels emptied. Ferry bookings surged. The island that draws millions every summer for its beauty and calm sat largely quiet under emergency conditions, its streets less crowded than they had been in decades. For those who stayed, the experience was disorienting in ways raw data cannot capture. Living through 30,000 earthquakes in 30 days means existing in a state of constant, grinding alertness. Every tremor a reminder. Every quiet moment a question about what comes next. The scientific community watching the data was asking the same question. Something was moving beneath the seafloor. Something was driving this extraordinary, sustained swarm above Kolumbo. The answer, when it came, would rewrite the entire understanding of what this region is actually dealing with. In November of 2025, a study published in the journal Nature delivered the explanation scientists had been working towards since the swarm began. The findings did not simplify the picture. They made it considerably more serious than anyone had publicly anticipated. Santorini and Kolumbo, long treated as separate independent systems, are not separate at all. They are connected. Linked at depth by a shared magmatic reservoir that feeds both from below, they operate as a single integrated volcanic system beneath the Mediterranean floor. What happens in one does not stay in one. The conclusion came from a meticulous analysis of more than 25,000 earthquakes from the 2025 swarm, processed using artificial intelligence to extract detail that traditional methods could not resolve. What emerged was a picture of magma on the move. Sheets of molten material had sliced through the crust at depths greater than 10 kilometers, spreading across an area of approximately 20 kilometers. The magma involved in that single intrusion event would have filled 200,000 Olympic-sized swimming pools. The mechanics became clear. Beginning in mid-2024, the Santorini caldera had been gradually inflating, the ground surface rising as pressure built below. That inflation preceded the intrusion of a magma-filled dike sourced from a mid-crustal reservoir beneath Kolumbo. The two volcanoes were not reacting to the same external event. They were sharing material, exchanging pressure through the deep rock connecting them. The physical evidence was precise. The seafloor above Kolumbo sank by 13 inches, 32 centimeters, as magma drained laterally through the intrusion. Simultaneously, Santorini's surface rose by more than 4 inches, 10 centimeters, as that same magma redistributed upward. Two volcanoes moved in opposite directions at the same moment, driven by the same underground pulse. The researchers described it plainly. The two volcanoes were breathing together, inhaling and exhaling pressure through a shared network that had gone entirely unrecognized until the crisis forced scientists to look with new tools. The implications are significant. The question is no longer how dangerous Kolumbo is, or how dangerous Santorini is. The question is how dangerous the system is. And that is a considerably larger problem than anyone was prepared to confront. Kolumbo and Santorini together represent a serious, newly understood threat. But the Mediterranean does not stop there. While the scientific world focused on the waters northeast of Santorini, another volcanic system was sitting largely unnoticed in a different part of the same sea, carrying risks just as significant and receiving a fraction of the attention. Its name is Marsili, and almost nobody has heard of it. Marsili sits in the Aegean Sea, approximately 175 kilometers south of Naples. It is entirely underwater, entirely invisible from the surface, and entirely absent from the mental map most people carry of European geological hazards. The numbers describing it are not small. Marsilli stretches roughly 70 kilometers in length and 30 kilometers in width, larger than Mount Etna, the most closely watched volcano in Europe. It rises nearly 10,000 feet from the seafloor, with its peak sitting just 450 meters below the surface. By any measure, this is one of the largest volcanoes on the European continent. That it remains largely unknown outside specialist circles is itself a story worth telling. Italy's National Institute of Geophysics and Volcanology has raised specific concerns about what a destabilization event at Marsilli could produce. The volcano's walls are fragile, unstable, poorly consolidated rock, lacking the structural integrity of older volcanic formations. Its magma chamber sits at relatively shallow depth. These two factors combined, unstable flanks and a shallow magma source, make a partial collapse of the volcano's structure a credible scenario rather than a remote theoretical possibility. Researchers at the University of Bologna ran simulations of exactly that. In a partial flank collapse, tsunami waves would reach the Aeolian Islands in approximately 10 minutes, and the coastlines of Calabria and Sicily within 20 minutes. In the most extreme scenario, waves could reach 66 feet, 20 meters, striking densely populated coastal zones with almost no effective warning time. Kolumbo, Marsilli, the Hellenic volcanic arc. 3 pieces of a geological risk sitting beneath one of the most visited, most populated, most historically significant bodies of water on Earth. The threat is not theoretical. The infrastructure to address it is not yet adequate. And the sea above remains, on the surface, perfectly, deceptively calm. The picture that emerges from all of this data is not a comfortable one. Beneath the Mediterranean, across a region that has hosted human civilization for thousands of years, a set of geological systems are active, interconnected, and growing. The science is no longer speculative. The question is not whether these systems pose a serious risk. It is whether the world above the waterline is moving fast enough to respond to what the world below it is telling us. In December 2025, the research vessel Meteor departed for Santorini carrying the Multimar expedition, a mission specifically designed to test and deploy innovative submarine monitoring systems in the waters above Kolumbo. Next-generation instruments capable of detecting and transmitting volcanic activity data with a precision previous equipment could not match. It was not symbolic. It was a direct scientific response to everything the 2025 swarm revealed about how much was happening beneath the seafloor that existing systems had been missing. The Santorini Observatory has tracked Kolumbo continuously since December 2022. During the 2025 crisis, new seismographs were installed inside the volcano's crater, positioned as close to the source of activity as it is physically possible to get. The data flowing from those instruments is being analyzed in real time by research teams across Europe, advancing the understanding of this dual volcanic system faster than at any previous point in its study. That progress matters, but monitoring alone is not preparedness. The gap between detecting a threat and protecting millions of people from it requires infrastructure, evacuation planning, public communication, and political will that does not yet exist at the scale this region demands. Tsunami warning architecture cannot be built in a week. Evacuation plans for islands with only minutes of potential wave impact cannot be improvised in the middle of a crisis. What is happening beneath the Mediterranean is one of the most significant geological stories of this generation. The magma chamber beneath Kolumbo has been filling for nearly 400 years. The connection between 2 major volcanic systems was unknown until 3 years ago. The largest submarine volcano in Europe sits largely unwatched south of Naples. The sea above remains beautiful. The question is, how long beauty and danger can share the same water?